Seoul's got an air quality problem. There's already a lot out there on this. You can see all kinds of stuff on YouTube. This guy is obviously having a bad day. He's being very affected by the dust, but so are a lot of other people. There are online resources that show you the actual dust data. I think the most prominent one is aqicn.org. You can go here and get real-time data on the current state of affairs wherever you're at in the world. Right now we're looking at Seoul. Here's their view on the entire world, and you can see that Australia, Scandinavia, and parts of US and Canada are full of goodness. But it's out in Asia that we have at least a measured problem on display. It's been conventional wisdom that this is pollution coming to Korea from China as a combination of both industrial pollution and also dust from the Gobi Desert. But if you zoom in on Seoul, you see that Seoul itself is actually showing a high level of pollution, whereas the surrounding areas aren't so bad. But this indicates that this pollution is probably locally generated rather than coming over from China. But you don't really need the app to know there's a problem. Here's a blue sky. I found this on Google. But this is what we have if you actually get up from a desk and walk over to the window. This is what Seoul looks like right now. So there are web apps with APIs, and also we can see with our eyes that there's a problem with the air quality. So why would you need a dust sensor? Open your windows. Are you getting this dust in the house? Are you getting the dust even if the windows are closed? Is your HVAC system injecting the dust into the house from somewhere else in the building? Or is your air filter even working? These are questions you may need to answer. Here's the V1 dust sensor that Suhi and I have been working on. It's got a GP2i10 dust sensor attached to an AppMega 328, which then talks by XB S2C radio to our gateway. The gateway in all cases is going to be a Raspberry Pi that has an XB radio attached by way of a custom board we attach to the GPIO ports. So what you've got is you've got two industrial grade radios talking, which are then hard connected to the Raspberry Pi GPIO, which has an Ethernet connection. So this is very reliable. We don't have problems with internet connections or lost packets. So we've been using this device to gather data for about a month, and we're getting good, reliable data. I believe this is uploading every 30 seconds. This is data that's being sent directly to the OhioIoT app. So this gives us 5 time frames. We've got a snapshot, which is 2 hours. We've got a 24-hour graph. We've got a 1-week graph, 1 month, and a year. But really, it's only been running for a month, so that's what we've got. You actually see that there's a cyclical pattern. The dust sensor is affected by temperature. So when the day warms up, it actually gets a higher reading and a lower reading when it's cool. But you can see that this is 0. And for the first couple of weeks, we were getting very good clean air in Korea, or Seoul. And then a couple weeks ago, it started to increase. And right now, we're actually spiking. And that's why you see that view out the window that I showed you. Hello? Hey, I'm working on the dust sensor video. So for this V1 device, you've got the actual end device itself that talks by radio to the gateway. And this gateway is great if you want to have some sort of smart home system. So once you have a gateway plugged in your house, any device with the right radio configuration can talk to it. So you can put all kinds of devices around your house and build up your smart home. But if the only thing you want to do is sense dust, you're not going to want to pay for all this. So we started working on the V2 board, which is going to use the ESP8266. In this case, the Wemos D1 Mini, attached directly to the same dust sensor. So again, the V1 device was going to be an AppMega device that talks to a gateway, and that's part of a smart home system. But for the V2 device, we eliminated the gateway and reduced this down to a Wemos D1 Mini. And the D1 Mini is so cheap, we don't even have to just take the raw chip and give it the surrounding hardware. Instead, we could put the dev board right on the PCB. And you see the only two other things that were added here is the capacitor and resistor that you need to operate the dust sensor. So there's really only 4 components total on this board. Pretty efficient. In order to get some good testing out here in Korea, we had to build some development hardware to bring out from the States and start to put it in windows in apartments and see what we get for results. I plugged 2 sensors here into the apartment that you just saw in the window. Now one of them was working fine, no problem at all, but the other one you see kind of worked a little bit, shot off a data point here, and then put another one here. So the thing worked 3 times intermittently, and besides that was off. I got the same results with the third sensor that I took to Burn and Hal, the cigar bar. It worked, it didn't work, then it worked again, then it worked again, then it worked again, but spent the rest of the time not submitting any data. So these things aren't working that well. I went to Burn and attached my laptop to the dust sensor I had installed there, and I wanted to monitor the serial port. And you're going to see a pattern here that I've seen several times before. The first web hit fails, and it resolves that failure and continues on and gets another data point, but you see the second time it just hangs up completely. When this happens, it doesn't recover. I've got all three sensors here, and I got to figure out why they're locking up or hanging up on those web hits. I'm going to plug this guy into my laptop, pull up the Arduino code, and reprogram it and just watch the serial monitor, see what happens. The hang-up happened after the serial monitor reported the HTTP. Let's come to the Wi-Fi code, and you see that we serial print HTTP : and then we do a GET request. We're sending our internet request to the OhioIoT server. After you do the GET request, you ask if the HTTP code that it returns is greater than 0. If it is, you'll be serial printing that. If it's not, you'll be serial printing that there's an error. But you notice that we don't get any serial prints, so it seems like we don't get this far. There's something wrong with the HTTP GET. So I have to dig into that and find out why my GET request is hanging up. Or at the very least, even if the GET request hangs up, we should set it up so that it can just accept that and keep moving on instead of locking up completely, which it seems to be doing. Thursday morning, what do we have? So check out my breakfast here in Korea. We've got two different cakes. This is rice wrapped in seaweed. One is filled with tuna and mayonnaise, the other is filled with Spam. See, rice inside of seaweed. Spam. Let me explain really briefly what we're doing here. I've got some Arduino code, and you see there's two libraries. One is Wi-Fi, one is Dust. I took all the code required to securely hit the OhioIoT web app and put it into a library so that I don't need to think about that anymore. All I have to do is give it the SSID and password for the Wi-Fi that I'm using and give the device a name, and then I can just say Wi-Fi hit route and it will send the data securely to my app. Dust is just taking the standard Arduino code you need to run the dust sensor and putting it also in a library so that all I have to do is say what pins it's attached to, and then I just tell the code to read it. So what we're doing is initializing the Wi-Fi and the pins, and then we're looping through saying read the dust, send that data to the web. I'm going to make a new public facing account that you can access. This value ties this device to an account. I'll show you what I mean. Let's call this for video. And we're in the apartment, and this is the first one I'm doing, so we'll call it apartment 01. This is dust data. You see that we're going to hit the web with dust data, and we're going to put the room, the ID, and the value. It's right here, actually. This is what we're uploading to. But we're sending the data. Okay, so where are we sending the data to? I'm going to make a new account. Let's call it guest, and you are welcome to log into this account. I think as I add different devices to the system, I'm going to send the data to guest, so other people can see what's happening. So let's go to OhioIoT.com and create a new user. Now the device ID is for video. That is what we put here. So this is going to send data to the for video account, and this is going to log us into the for video account. So I submit this, and guess what? There's the data. And then look, the data point is named apartment 01. I'm gonna program another dust sensor and call it apartment 02. Done uploading, and now watch over here. There you go, apartment 02. I'm gonna go plug this in. I'm gonna program this one as apartment 03. It's done uploading. There it is, 03. Two things to address are, one is that these individual sensors need to be calibrated, and I have no way to do that just yet. The second is these are affected by temperature, so we have to adjust for that. And the third thing, which is a problem, is that these things just stop. So as I showed you before, after we say HTTP, it fails one time and then it stops altogether. I need to figure that out, but I'll tell you what, for now we've got data coming in. Let's just enjoy. Check this data yourself. Go to app.ohioiot.com and then log in as guest, all lowercase. Dataset's growing. Check it out.